welcome everybody. We appreciate your digital presence here to listen to this exciting presentation from Marin. Marin, as you may have read maybe in the invitation, he is an engineer that works very actively with us, Engineer Without Borders. So actively that sometimes I think whether you have ADHD and like me, but no, okay. And he has been at Eco Moyo to help them over there with several practical things and in several engineering fields. So I'm not going to go through it so he can do it himself. I just want to mention everybody that the session is being recorded. So therefore, by you continuing in this connected and participating, which we hope you do, you accept that this is recorded and you are part of it. I ask you to mute your mics and we allow Marin to finish his presentation. And after that, we can lose off all the cheating, same origin also, with all the questions. So, Marin, the microphone is yours.
Thank you. And thank you for joining the presentation on water situation and other challenges, engineering-related challenges at Eco Moyo. For those who have not met me, my name is Marin Prebeg, and I have been involved with Engineers Without Borders for about 2 years now. And the latest thing I did, or recently with Engineers Without Borders, was visit to Kenya in February this year, where I did the work I'm going to present now. And the brief presentation is going to revolve around some background about what was done and where, since we have some people who have not been at the school and are not familiar with it. And then I'm mostly going to talk about the water supply network at the school. We did many other things. We did some other things related to water supply, such as maintenance, water filter, and water demand. We did some work related to solar panels. We had some discussions on rainwater harvesting, erosion, irrigation, and so on and so on. But because of the length of the presentation and the scope, we will mostly focus on the water supply and leave the rest for discussion later or afterwards. And I'm going to say something about the engineering committee, which is one of the main outcomes of the visit, and we are going to close with some brief conclusions. And so brief background to start with. Where in Kenya is the school? It's close to the coast, 2 hours north of Mombasa, for those who are not familiar with it. And it looks something like this, for those who haven't been there. The school is attended by approximately, I think, 250 students, something like that, every single day, who are living in the area around the school. And part of the staff is living at the school quarters itself, while part of the staff is coming to the school on a daily basis. And the work presented here is presented in more details in the report we have written for Engineers Without Borders, and it is building on several master's theses written about the school. That being said, that's so much for the introduction. Now we move to the water supply. If there are some questions along the way, if something is very confusing, I don't mind getting questions along the way, but we can also take it all afterwards. So here is another look at the school, this time taken from Google Earth. And one important information here, or for reference, is that the school property is around 300 meters long and around 160 meters wide, depending how you look at it. And another important perspective on the school before starting in more detail is that the school property is on an inclined area of about 30 meters. And that is important because the water supply at the school is gravity driven, which means that no pumps are used or anything like that. All the water being used is flowing only due to gravity. And herein on this map, I will ask you to ignore these white contours here. It's not of relevance for this presentation. It is just an image I took from somewhere else. That said, we actually move to the water supply network. The water supply network at the school consists of 15 tanks. And 8 of those tanks are rainwater tanks, which means they are filled only by the rainwater and they are not connected to the rest of the network. And these 8 water tanks are approximately located at the following locations. Those familiar with the school might be able to recognize that this is director's house, these are classrooms, and so on and so on and so on. For those who are not that familiar with it, it's not critical for the points we want to bring out. So we have 8 rainwater tanks with storage capacity of a little bit about 40 meter cube. And we have 2 tanks which receive municipal water with a total capacity of 20 meter cube. And this is the only water that is coming to the school outside from the rain that is falling on the property. So this is, as of now, our only connection to the municipal water system. And in addition to this, we have 5 water tanks which are connected to these 2 municipal water supply tanks. So the blue tanks are rainwater only, they're standalone, they have tap on themselves, which can be, and water can be retrieved locally. We have 2 municipal tanks which are filled with water from the municipality. And we have 5 yellow tanks which are filled with both rainwater from the nearby buildings, and they are connected to these 2 tanks at the top with a system of pipes going around the property, which is not shown here, but you are going to have a look at it. Let me see if I'm missing something here. Sorry for the quick delay. I don't think I'm missing anything. So that is that for now. And another 2 figures we have just from the report is that we can see that in the report you can see the size of each individual tank on the left side. We did not show that on the presentation. And you can see a full water supply network of the school, including the taps. I have not shown water taps in the previous image, not to clutter it too much, and because it is not critical for what we would actually like to discuss here most. And what we would like to discuss are 3 to 4 main questions that were left unresolved during my stay at the school, or I did not learn the answer to those questions. And I think they are all important for the future development of the water supply at the school. So we are going to go back to this slide, and we are going to drop the rainwater tanks because they're actually not connected to the supply. So we are going to focus only on the 2 tanks providing water from municipality and 5 tanks connected to those 2 tanks. The next thing we are going to do is that we are going to use slightly different colors because these 2 water tanks at the top are each supplying their own water supply network. So in practice, it looks something like this. The rightmost tank, which is closer to the gate for those familiar, is actually supplying with water all 5 tanks connected to the water supply network. That's the one in the kitchen, in the classroom area, and at the teacher's quarters. And the first out of 3 questions which I was not able to find out is, how does exactly water supply network looks around the classroom area? It was left a bit ambiguous in which order are the tanks filled and where exactly are the pipes going. And that is something that would be useful to know. A brief note here is that each of these tanks have a gate valve, so the water is not flowing from the top tank into them immediately unless you open the gate valves. So if you open the gate valve here, the water is going to start flowing from this tank into the tank down here. So you can have access to water down here. Which brings us to the second question. As mentioned now, if you open a gate valve here, this tank is going to be emptied and the water is going to flow into this tank. If you open a gate valve here, this tank is going to get emptied and the water is going to start filling these 3 tanks. But according to some people at the school and according to some of the discussions which we had with the people at the school, if you open a gate valve here, the water from first tank is also going to flow into this tank or into this tank. Which brings us to the second question, and that is, are the water supply networks 1 and 2 somehow connected? We tried to do an experiment about that with Lucas, who is here with us, but the results were somewhat inconclusive. And while we were at the school was facing water shortage, so we could not afford ourselves to play with water back and forth and waste too much of it. And starting and closing and opening and filling and emptying the system is kind of dangerous and not a good thing to do, at least not very often. So the first question is, how does this network looks here where the lines are dashed? The second more important question is the network number 1 connected to network number 2? And the third point is more of a statement and then also a question, and it is the following. When the water is coming to the school property from the municipality, it is going into tank number 1, it is going into tank number 2, and it is also connected directly to the water supply network number 1. It's not going only through the tanks, the water is flowing directly from the municipality to the water supply network 1. And now comes a main question or a conclusion, and that is, if the water supply network 1 is indeed connected to water supply network 2, which is connected to all the tanks, that means that we can direct water directly from the municipality into the tanks on the property, all the tanks on the property, which means that our municipal water storage capacity is not only 20 meter cube here, it is 20 meter cube plus 28 meter cube, which is in total almost 50 meter cube. But that depends on the fact if these 2 systems are connected, and in practice it would imply some other intricacies, which we don't go into here now. So those are the 3 main questions. How does the network look here? Are those 2 networks connected? And does that really mean that we could direct municipal water directly to the whole system and not be restricted with the storage capacity of these 2 water tanks? The second topic, kind of related to this, but slightly different, is that Let me just click on that. Yeah. So this building here is a multi-purpose hall that some of you are familiar with. And next to it, there is a plan to build a large underground water tank with a storage capacity of approximately 100 meter cube, if I'm correct. And one of the main purposes of that tank is to supply this garden with water for irrigation. So the idea is that the roof of this building would redirect water into the tank. The water from the tank would be pumped uphill, perhaps stored in a temporary tank, and then used for irrigation of the garden at this part of the property. As for now, these two systems and the system that is going to be part of the underground water tank are not connected, and it has not yet been decided in which way we are going to connect them. But there are multiple questions arising here, and I'm just going to order them kind of off my head without a plan to necessarily resolve them right now. It's more just to show that there are many things we have to consider here. And that is, for example, what is the water from the tank going to be used for and how much of it? Is it going to be used only for the garden or for something else as well? The second is, how fast do we plan to fill it with the rainwater from the roof? And what is the balance between the water that will be going in and the water that will be going out? Do we perhaps plan to use more water than we can actually put into the tank? And if we decide to connect the tank system to the rest of the system, is the main purpose to redirect water from the school property into the tank? Or is the main purpose for the tank to be a backup for the system when the existing system runs out of water? And then we have a question, is there going to be a tank here at the top of the property? And there is a question, if that water is going to be used for irrigation, should the municipal water also somehow be redirected in case the tank does not have enough water for irrigation? And if the water is going to be pumped uphill from the tank to the top of the property, are we going to install a local solar pump, or are we going to connect the tank to the rest of the electrical grid at the property? So there are a lot of small questions that need to be clarified ahead of starting to plan how do we and if we integrate these two systems or not. And one of the things it depends on, and I have not touched upon it here, is the water demand at the school. And we have quite bad idea of how much water is actually used at the school and what is it used for. It is something that we could definitely improve, and it is an information that we could benefit from. That is all about the water supply. The next and second to last main topic is the engineering committee. So while we stayed at the school, we often felt that we lacked information about what was done, when it was done, and by whom it was done. One example of that is the outlay of the pipes and the water supply system and so on. The thing has been done over years, and it has not necessarily been recorded. Yes, who did it, when did they do it, and so on. So one of the things I proposed is to establish an engineering committee, which was done, and part of it are Dominic and Gregory, who are unfortunately not here, and also Kazungu, Gardiner, and Malimu, who is caretaker. And we started leading a diary on a shared drive, a brief print screen taken here, where we are trying to record engineering related and important events at the school. What broke down, who fixed it, when it was fixed, phone numbers of relevant people, and so on. So the idea is to keep it as a record of what has been happening at the school, both not to forget it, and also if there is a change of people working and living at the school, that you have some kind of a track record of what was happening before they came to the school. And as a part of that document, we are also taking measurements of the water meter on a weekly basis in an attempt to better establish how much water is being used by the school and how much water is being delivered by the municipality. And that brings us to the last slide, where instead of some broad conclusions, I just wanted to list some other collaboration opportunities that were discussed and that me, Lindsay, and Francisco discussed just a few days ago. I think it was last week or something like that. So you can see that there are a lot of potential for future projects and collaboration opportunities, and I think they are all worth pursuing. And with that being said, I can say thank you for your attention, and also thanks those present who enabled me to visit the school. So that brings us to the last slide.
Thank you very much, Mari. It was a fantastic job, and I will assume that Lindsay, Mali, and the rest of the team over there will have a very good benefits, much benefits out of this, and of course, good that you set the path for continuing with it. I open now the mic for questions, comments. Anybody, unmute your own mic and just present yourself quickly or your name, and then go ahead, one at a time. Go ahead, Lindsay, please.
Yeah, so I just wanted to thank Marin for a wonderful presentation. It's interesting because you would think that we that are on site should know how we've set things up. And looking at this presentation now, I'm like, holy mother of Joseph, what have we been thinking about? But this makes it so much easier for us to at least try to plan a way forward. And I think it's just worth mentioning as well that I don't know if it's a goal to try to capture as much municipal water as possible because of the cost rather than rainwater. So but I haven't spoken to the rest of the crew about this, but I personally, you know, keeping the water bills down is a great concern. So maxing the amount of cubic meters that we can fill all our tanks with, yes, for rainwater, maybe not for council water. I don't know. It was just a few thoughts that I had. And also an input on the question about how are the pipes connected in the center area where you had the dotted yellow line. I don't know exactly. I mean, I know roughly how they are connected, but sorry. But I think an important key element here in the whole mystery about can these two main lines, can they be connected, or are they connected at some areas? The point is that we're using gate valves to close off rain and municipal because of the drinking water situation, so that we know that we have certain taps that are always clean drinking water from the municipality. Sorry, I just wanted to say that. Sorry, let me turn off this. Yeah.
Yeah, I can I can reshare the presentation if it's needed. Yeah, as for redirecting the water from the municipality to the downstream tanks, definitely not necessary a plan. That was not intention to imply, but just kind of to understand, is that an option? And also, if that is something that we can do, but we don't want to do, then it's also important to know so that we don't do it against our will. Because if it's possible to do it, that means it can be done by a mistake. And that is something we would like to avoid that. For example, we might unwillingly redirect water from the tank number 1 to the teacher's quarters or a classroom area without actually wanting to do that.
Yes.
What may be also very interesting as a possible development into the future is to see the possibility to have automatic systems. If we were to have electronic floaters on each tank to know how full of this the tank, you will know at any moment how much water is available to the whole area, and then based on that you can control the amount of amount of water that comes from the public lines. Just following what you just say, Lindsay, about to minimize the amount of water of the public lines, water lines, to reduce the costs of that, and then by maximizing the use of the water from the rainfall. Lucas, go ahead, please.
Sorry, can you hear me?
Yes.
I was wondering if we have any idea how big the proportion of is regarding how much we use from the municipality and how much we use from the rainwater. Because if we want to kind of utilize the water we get from the rainwater as much as possible, what do we want to use it for? I think is an important question. And considering that how much water goes into drinking, it's surprisingly little compared to how much water you use through a full day. And I don't know how we or you have been looking at using the rainwater in general, but according to a lot of standards and professionals, you should not initially drink rainwater, or at least only rainwater. You can also turn on the camera. But yeah, my question is basically if we have any idea how much we use from the rainwater and how much we use from the municipality water. Because it seems like, if I understand Lindsay correct, that we want to become more and more self-sufficient based on rainwater, if possible.
Well, it will be more and more self-sufficient on water supply that doesn't cost them. Like you talk to me, or you have mentioned, Lindsay, on this well, for example, for the possibility of a well, in order to treat both the rainwater and eventual water from a well in such a way that can be drinkable water or clean enough. So, and all of this with the objective of reducing the costs that they have to pay to the municipality for the water they take from them. But just jump in, guys. I mean,
okay.
the discussion is open. Just jump in.
Right. So yeah, so you're referring to, I think I was mentioning the reverse osmosis system, the desalination plant. Yeah, because when I looked into that, like, I don't know, 5-6 years ago, it was like utopia, and then now it's actually becoming more and more common down here to do that. And we already have a borehole that's so salty that if there was a solar pump or a solar-driven system to desalinate the water, it could also solve quite a bit of our problems. So that's an interesting project to look at as well. But yeah, I was just gonna respond to that.
But what Marin set up, all these records that he set up with the engineering side and how it's used, that will help very much in order to start quantifying the different needs. What do you need as a gray water. And again, yeah, you mentioned also the reutilization of the gray water from the kitchen, etc., for example. So yeah, it's a bit challenging to dimension and decide something without having an idea of the volumes that we are talking and the flows, how much. So following the scheme that Marin has discussed with you guys will help to start making the basis for making further brainstorming about what will be a system that will be most effective for you guys using the water on the different levels of cleanliness.
And also, I also think the challenge is that you know, when we don't have rainwater, we have to open gate valves to fill the tanks with the municipal water. And then, you know, having a routine of opening and closing and all that jazz. And, you know, a tank is down by the teacher's unit. So maybe it's raining, but maybe they don't really care. So they're just leaving it open. Like there's all these internal routines that is also a challenge, right? Because it kind of demands you to really be so focused on that. So it's a great initiative that we have a group. Sorry, Gregory is not here right now, but yeah, hopefully we can do that.
Marin.
Yeah, one thing I wanted to mention about the water measurements we are taking right now, I think they will be useful for us. But one small minus right now is that we do not know if the certain amount of water was delivered because the municipality did not have more water to deliver, or because the tanks got full, so the valves closed, so the water stopped flowing. Because when the tanks are full, they have automatic valve which is going to close them. That will require us to also check the level of the water in the tanks and so on. But it is a step forward. And another impression I had when we were there, it was perhaps the most water scarce period school experienced in a very long time. And I actually felt, talking to Gregory, Dominic, and some other people, that for most of the year, the school is not facing severe water shortages. But then when it is, then municipal water is the only water that is available. That was my impression, that it's actually 7, 8, 9 months, perhaps some rain or some rainwater from previous rain period and so on. But then when it gets dry, it gets really dry for a month or two or something like that. And then we really don't have any other choice except municipal water or storing immense amounts of rainwater, or, for example, desalination or something like that. And that is also something that was a bit, so both water demand at the school has been very ambiguous. It went from 50 meter cube per week to 45, so very large span between different sources and methodologies, but also the amount of rainfall at the school has been also, the estimates varied a lot based on meteorological data or experience from people and so on. So those two factors play into what is the best water strategy in the long term.
But I mean, I don't know to which extent you guys in Eco Moyo could be prepared for some automation, as I say. Come on, companies like Statkraft, they very much set the prices of the electricity here in Norway, where we have so much hydropower based on the rainfall and the snow melting. Statkraft makes pretty accurate predictions of the weather or how much water will be and so on. So the know-how is there for, okay, if it's such that it's critical for a long period of time, I don't know, 2 months, 3 months, 5, 6 months, 9, 1 year, how is the prediction of how much rainfall gonna be? Then that and an automated system to measure the level of the tanks and to open and close valves, etc., will resolve quite a bit, on top of having the solution of the water well, the cleanliness of the water, desalination and other minerals and so on. So it could be possible to make it kind of the most efficient and the most useful for the school, but then yeah, it implies a bit more analysis and investigation of what is actually the most convenient system for you guys over there. I mean, that you know, that can be installed in a way that you guys can maintain it, because if at the end, as we say in Mexico, it's more expensive the soup than the meatballs, then it's not exactly the best.
Yeah,
All
so
right.
there is definitely room there to gain more knowledge also. The one idea would be also to do some experiment of school employees trying to measure, determine how much water we actually use, as Lucas said, for drinking, cooking, cleaning, gardening. About that, we have also, I personally was not able to gain very good insights. So both total water usage and how much water is used for different activities, which require different quality of water, of course.
Yeah.
Martin, I think you just have to come back and stay at Eco Moyo for 1 year and get all those measurements very correctly.
That is not so unlikely.
Can I carry your suitcases?
I would love to do that one day if it will be possible.
Any other questions, comments from anybody else? We are approaching the estimated time. Yes, go ahead, Lindsay, please.
I mean, based on what we've seen here, I mean, it's a question for Martin, but also others maybe. Because when I'm looking at this presentation, a part of me is like, what the hell were we thinking putting all these pipes here and there? But does anyone see any other very logical way? Like, it's probably not a quick fix, but is there a logical way of repiping everything that would make much more sense?
By all means.
I just have to say, since I was mentioned, so I wanted to raise some questions on how the system works, because some of the things were not clear to me. I did not mean to imply, most seriously, that it couldn't be done better in any way. I'm not an expert myself, of course, on that. So the main goal was to understand how is it working now. I don't think the fact that all tanks are supplied by one municipal tank and not combination, something like that, is good or bad. So the main goal was just to understand, because to improve it, we need to know how it works. But I don't think that this is in any way bad, and I did not see hundreds of water supply systems myself. So just it was not intention to make a criticism of existing system, but just to understand better how it works.
No, I didn't take it as that either. It was more of an open question at all, because I just felt it looks so complicated. I mean, you're making it as clean as possible in your presentation, but we've been looking at this for a few years, and I always get so confused every time I see this thing. So I was just kind of putting it out there. Is there some obvious things that people are seeing that, yeah, but
I can reserve my comment for later. Lucas, go ahead.
Yeah, taking it for what Lindsay said, I think at least going forward, because what has been done before, it's hard to kind of redo. But going forward, as there is plan to build a water tank and probably another or extend the existing water system, I think it's important that we have a plan and a good understanding of how we implement that in the best possible way. And that's also some of the questions which Marine also raised. And if you go back, could you show the presentation, Marine?
Yes, I can do that.
And if you show the plot with all the water connections or the whole water system.
Hand drawing.
No, the other one, which is kind of the potential also, with the new one or with the water tank.
This one.
Yeah. And I think it's because what is already existing, I don't know what we're gonna do about that, but I think we also have some important questions to answer for building the new system or increasing the system. And if if you say that the salinity or a water desalinity system where you use a well actually works, if you don't actually need a water tank or not, because when you have a well, you usually have a quite stable flow of water income. I don't know. I think it's important to set a proper strategy before we at least start putting or start building something. I don't know what you call it, but in Norwegian it's called a mulighetsstudie.
Feasibility study.
Yeah, feasibility study. I think it's important to kind of see what kind of options we have, how the market is, how much things cost, and what is better for Eco Moyo. And it's kind of difficult to predict what's going to be there or how much prices are going to change in 10 years. But I think as for now, at least when Lindsay and Eco Moyo starts collecting or start fundraising, that we have a plan for what kind of system we should design or implement at the plot.
It is a good point, Lucas. However, just thinking aloud, I will say I have a couple of points there. One is, if I understood Marin correctly, when you guys were down there, it was one of the driest periods that has been experienced in the area. Considering a bit these climate changes, the question is, are these going to continue or maybe increase later on? So in that case, to ensure the supply of water for the whole school and everybody in it, in the area, in the campus, it is important. And then the second, if they were, I don't know how will be the possibility for Eco Moyo, that if they have an excess of water, they could even sell it or give it to or give access to other people around. I don't know the conditions around and so on. So I will be more inclined personally towards if there is a possibility to have all these sources, then yes, by all means, make the analysis so we don't walk in as blind in the road ahead. But I will be more inclined that if there is a possibility, go ahead with each one of these was mentioned than not. Go ahead, Marin.
Yeah, no, please finish.
No, go ahead. Yeah.
I just wanted to add one thing, building a bit on what Lindsay said, going one step back and what you mentioned a bit, what could have been done differently, not necessarily better. One suspicion we had, and just going to reshare my screen briefly for this. One thing that is the case in the school is that the two tanks at the top of the property are around 2.5 meters tall, and they are about 2.5 meters above the water supply network pipes. And the inlet to the tanks is at the top of the tanks, which is at about 2.5 meters height from the ground. What we observed at one point when the water was coming to the school, we are not 100% sure about that, is that the water was coming from municipality through the municipal pipe, but it was not flowing into the tank because it did not have enough pressure to climb 2.5 meters to flow into the tank. That is our suspicion, that at one point the municipality was willing or trying sending in water, but the water was under such a low pressure that it was not reaching the top of the tank in order to flow into the tank. So that is something where this could help us. If we could redirect water to flow directly into the system and into the tanks below, we could retrieve some water from municipality when we really need water, but the water does not have enough pressure to flow into our tanks. Alternatively, the different solution would have been to install the tanks approximately 2.5 meters lower on the property. That way, the municipal water supply system would be above the tanks, so it would be easier to flow in. But how often is this the case, that the municipality is sending water but just not enough pressurized in order to flow into the tanks? I'm not 100% sure, but it is something that we might have observed while being there, that we were told the water was flowing to our neighbors upstream of us, so they were getting water, but they might have been fetching water themselves, and by the time water came to the school, we could hear it in the pipes, but it was not flowing into the tanks. If that makes sense, hopefully it does.
I have no doubt that it should be possible to map completely the whole network of pipe down there, but one important factor is to be able to make tests. And I understood that they were Marin and Lucas and the rest of the team were a bit limited because of the conditions of when they were down there. So yeah, we can look into that possibility again later on, discuss it, brainstorm it, and see how could you guys finish mapping these other areas that are still a bit uncertain.
Yeah.
Any other questions or comments? Anybody? The last one. Hold on. I think there is something in the chat here. Yeah. Okay. Lisa, have to go. Thanks for a very nice presentation and discussion. Okay. Anybody? One.
Wow, Gregory is here.
Hello, Gregory.
Hello.
Yeah.
Nice to meet you.
Okay, so he got the last part of it, but maybe I think the presentation can be sent to us, yeah, so that Gregory can also look through the presentation on his own.
Yes, I will.
Remember, this is being recorded.
The recording, yeah, the recording
So-
would be really good for Gregory and Dominic to also see. Yeah.
Yeah, I'm sorry to be late.
Not your fault. Okay.
That's live. Welcome.
Thank you.
But okay, if nobody else has any other question or comment, I don't see anything here. Then I just want to thank Marin for his cooperation, his goodwill, his initiative, the super activity that he has always is very nice, inspiring and motivating. Thank you very much, Marin. And once again, Lindsay, thank you very much for allowing us to help you guys and fulfill through you, as with some others, the mission of Engineers Without Borders. And again, more than happy to continue trying to find solutions so you guys can have better conditions down there in whatever way we can. Thank you very much.
Yeah.
And we continue talking and planning for the future.
Okay, thank you very much, everyone, for attending. Have a nice day.
You too. Bye-bye.
Bye.
Bye bye.
Bye.